A factory minimizes production costs and maximizes output, a highly rational, efficient private transaction. Yet, a mile downstream, industrial runoff destroys a coastal reef. To an ecologist, this is pollution. To a public economist, it is an externality, a term defined strictly as a missing market and a failure to assign property rights to a shared resource. Because no one holds the deed to the ocean, the cost of polluting it is zero. The market reaches an equilibrium, but it is a false one, calculated based only on private ledgers. This chart shows that false equilibrium. In a standard market model, the supply line represents the marginal private cost of production, and the demand line represents the private benefit. They intersect to set the market price and quantity. But in the presence of a negative externality, the true cost to society is always higher than what the producer calculates. We draw a new line above the private cost, the marginal social cost. The vertical gap between these two lines is the uncompensated damage absorbed by third parties. This vertical gap is a structural flaw in the market's architecture. It dictates how resources are consumed, and we can model its exact mathematical impact. We see this theoretical failure operating at scale across Indonesia, driving the tragedy of the commons in both its marine and forestry sectors. This unpriced action creates an illusion of efficiency. It actively destroys wealth because the private math ignores the social reality. Returning to our graph, we can isolate the exact cost of this missing market. Because the producer's costs are artificially low, the market produces too much of the good. The area shaded red represents the resulting inefficiency, deadweight loss. It is strictly defined as the zone where the true cost to society is higher than the value provided to the consumer. As production shifts right, past the social optimum, the loss expands. This deadweight loss is the engine of the tragedy of the commons. It occurs when goods are non-excludable, meaning you cannot stop someone from taking them, but rivalrous, meaning whatever one person takes leaves less for everyone else. In Indonesia's maritime sector, IUU fishing exploits this missing market, generating an estimated 300 trillion rupiah in economic loss annually. This theory is grounded regionally in archipelagic zones that rely heavily on marine resources, such as Nusa Tenggara Timur. Because there are no defined property rights over the open fishing grounds, individual fishermen only calculate their fuel and labor. Their marginal private cost ignores the depletion of the stock. Every vessel is economically incentivized to extract as much as possible. This localized missing market dictates rapid overexploitation and systemic economic loss. Deforestation represents the exact same mathematical failure on land. The cleared acreage represents private profit, while the lost ecosystem services and carbon capture represent the uncompensated marginal social cost. In unowned spaces, perfectly rational private extraction mathematically guarantees systemic public ruin. To eliminate the deadweight loss triangle, governments must intervene. Public economics provides three distinct tools. The first is the Coase theorem. It suggests that private parties can negotiate their own efficient solution. Coasian bargaining works perfectly, but only if property rights exist and the transaction costs of negotiating are zero. In practice, Coase fails from massive issues like Indonesian deforestation. Coordinating millions of actors incurs impossible transaction costs. This leads to the second tool, Pigouvian interventions, or price methods. Here, the government calculates the exact marginal damage and levies a tax of that same amount. The producer is forced to internalize the public cost. Historically, Indonesia ran this in reverse through fuel subsidies. By artificially lowering prices, the state acted as a negative Pigouvian tax, subsidizing an externality and encouraging overconsumption. Correcting these price-based fiscal externalities creates immense socio-political friction, as seen during subsidy adjustments. When pricing becomes politically toxic, the state relies on command and control. The government dictates an absolute limit through regulations like AMDAL or forest moratoriums. When theoretical bargaining fails and price adjustments trigger unrest, governments resort to direct quantitative regulation to force market compliance. But this raises a technical question. Why does Indonesia heavily default to absolute quotas like AMDAL instead of implementing theoretically superior Pigouvian carbon taxes? The answer lies in Marty Weitzman's model of uncertainty. The government knows the environmental benefit of stopping the damage, but it does not know exactly how much it costs private firms to clean up. This guesswork creates a blurred marginal cost curve intersecting our steep benefit line. Choosing a price method, a tax, is highly dangerous when the marginal benefit of reducing pollution is incredibly steep. If the government sets the tax too low, the market reaction is catastrophic. The resulting dead weight loss triangle is massive. If firms find the tax cheaper than cleaning up, they simply pay it and continue polluting past the tipping point. Contrast this with a strict quantity quota. Even if the government guesses costs wrongly, the vertical cap contains the error. The dead weight loss triangle drastically shrinks. Weitzman's math proves that when environmental damage is steep and irreversible, strict quotas, not taxes, are the only mathematically safe intervention. At their core, externalities represent a fundamental failure. They are missing markets that, when left entirely alone, predictably generate a mathematically precise dead weight loss. While Pigouvian taxes internalize costs perfectly in theory, they require perfect information that governments rarely have. Pigouvian theory applies most clearly to centralized, high-emission industries like power generation. But the blunt reality of Indonesian governance, combined with steep ecological consequences in vulnerable regions like NTT, often demands a different approach. Economics provides precise tools, but the choice between them is a strict calculation based on the steepness of the environmental risk. Mechanisms like AMDL or fishing quotas are necessary mathematical guardrails. They ensure the market does not cross an irreversible threshold. Ultimately, to truly prevent the tragedy of the commons, the state must step in as the missing market, using targeted policies to force private ledgers to balance the public's reality.